Hi everyone, another teardown. What we got here is lab power supply. Let me just bring the camera down so you can see exactly what we're looking at. So we got Thorn automation limited, got power supply 0 to 40 volt and 0 to 50 amps. Yeah, some serious power stuff. This thing weighs a ton. You can see here, 2-man lift, 52 kilos each. I got 4 of these, and I'm just gonna open up to see what's inside this beast. I don't know how you're gonna put these on your workbench. I'm actually scared that my workbench might just break, so I'm quickly gonna take this apart. It's probably going to be a 2-part video again because my camera keeps cutting off. So it's built like a bloody tank, and okay, these screws on the side got crap on them, so I can't really catch them. You notice it didn't have any binding post at the front. What it's got these weird military plugs at the back. I'll just bring it down and show you. If you can see there. So those are the output terminals, and you got these weird looking military style sockets at the back. And this is how it is. Just gonna put the camera down. Let's see if I can open these screws. Yep. So let's see. Some of these screws got crap on them, so it's really hard trying to get contact in them. Nope. Oh. Nope, doesn't want to budge. Let's try a different screwdriver. Okay, what we got to do is we got to get my knife and just run these through, clean the crap inside them. I couldn't imagine anyone using these on their lab at home because they're just so heavy. I mean, it's ridiculous. It's a linear power supply, so we're going to have some massive transformer inside to be able to handle that kind of current at that kind of voltage. Okay, one of them is opened up. Yeah. We're going to have a lot of smoothing caps, because at that kind of current you will need a lot of capacitance to be able to keep the output nice and clean. Oh man, these screws don't want to open up. Oh. There's all kind of crap sitting on the screws. There we go. Ugh. Sorry, I'm not in the shot at the moment. It's because this thing is huge, and the distance from the camera and my bench is not that much, so it will come out of the shot. But we're getting there. I believe this is the last screw of this giant of a power supply. Oh man, even just taking the screws, you need to be an athlete. Whew, okay, I think that's it. Oh no, man, you got screws on the side as well. This is gonna take a while, folks. I seriously need a electric screwdriver. Oh, let me just move this thing around. Oh, oof. Jeez. This thing is a monster compared to any other power supply I have seen. This thing, it is so 52 kilograms. I think the actual chassis itself is at least 5 or 6 kilograms itself, because it is quite a thick metal work. So okay, let's see if we can open this thing sucker. Just hope my bench doesn't just break on me, my desk. Okay, we got the cow sticker here. I got all kind of cow stickers everywhere actually. So how do you take this thing apart? Don't tell me. Oh, for God's sake, yep. There is a screw here as well. There we go. Get in there. Ugh. Whoa! Check out the size of the transformer. Jesus, look at my hand. It is bigger than my hand. Then we got our output transistors. Look at the wiring. Then we got another transistor there. We got capacitor bank over here, and then we got the actual control board all the way at the front. So taking this apart, so we got two sets of 1, 2, 3. Yeah, 1, 2, 3. Yeah, so two sets of 3 heat sinks over here, and we got a huge HRC fuse over there. There we go, massive HRC fuse over here, and then we got a tiny little capacitor at the bottom there. Probably that is for control circuitry. And then we got another heatsink and some other, whatever this is, circuitry over here. Yeah, we got bridge rectifier and the rest of the stuff there. And then these wires, these thick wires, bring the output out to the back terminals where the actual thing is. So let's start with taking this massive transformer out. My God. Okay, so the transformers are STC brand, and let's just take it apart and then I can show you exactly what they are. So this is 40 volt, so even if the caps are charged, it's not going to be lethal. It will be lethal if I short them. We hear a big massive bang, probably, if this has been powered on. Let's just actually double check. I don't want to give myself... Okay, let's just see. No, we can see we got nothing on the capacitors. Yep, nothing on the caps. So it's safe to go ahead. Oh man, this thing is gonna take ages, and I got 4 of these to take apart. I just chuck the screws here, and then at the end I just empty the chassis when everything is done, and then just take the screws out. Man, this transformer is huge. Okay, so what we got some marking on the transformer. Let's see what we got on the transformer itself. Let's just get rid of these. Whoa, check this out. Okay, this transformer, we have 52 volt. I don't know if that's visible. Just push this. Oh! There we go, 52 volt, 48 amp. Jesus. That is a lot of current. And then we got some other taps over here. So we got 30 volt, 4 amp. And then we have some other voltages over here, which is not clear. Let's see what we got. This by far is the biggest transformers I've ever seen. Okay, so we have 10, and then let's see what else we have here. 10, 0, 10. So we got split supply here, split for the transformer. So we got 10, 10, and then 5 amp, and then we got 30 volt, 4 amp. So I would have thought that at this kind of current they would have used the, you know, multi taps, and then whatever voltages you dial at the front will select which tap on the transformer to use, because it's a linear power supply, so all the stress will be on the output transistors. So for instance, if this is, or the way it is configured right now, so if I'm dialing say 5 volt, the pass transistors are going to drop 35 volt on them, and at that kind of current, like say if I'm drawing, I don't know, 30 amp at 5 volt, this is what the pass transistors, how much voltage they need to drop, and that's crazy. But hey, this is Thorn. They make stuff for a military, so I'm sure they've done their homework, right? Okay, we got something here says aux 2, so auxiliary 2, 18, 18.5 amp. Don't see the point of that. Everything is hugely, oh man, it's gonna take ages for me to take these apart. As I said, I got 4 of these. So let's see what brand the transformer is. We got some brand info. Let's see what we got. We got PAR at 1 bit, then we got SON, and then we got AGE. So it's all supposed to be stuck together. Parsonage, maybe? I don't know. Never heard of them. Jesus, look at these transformers. I'll tell you what this will be good for. This transformer will be good for spot welding. Actually, spot welding you need probably up to maybe 10 volt. 40 volt, it's a bit dangerous at these currents. So maybe not for spot welding. Actually, I don't know what voltages they run at. I don't think they run at this high voltage at 40 volts. But yeah, I've got these massive wires, and then we've got these little pissant wires. So these pissant wires probably are just used for signaling for the base of the transistors. I still haven't seen what the transistors they're using for the output. Usually you get the 2N3055 in the old power supplies. It'd be nice to see what these people are using. Okay, so we got more of these silly okay. I think this fuse over here is a spare actually, because it's not connected to anything. Okay, so we've got these transistors, and we've got a little ceramic power resistor. My stupid camera focuses. There we go. 5%. W2200R. Is that 22 watts? Can't be. Maybe. Who knows? Anyway. Okay. So this is out. So all the wiring is off the transistors. Now the transistors are connected to little brackets on this side. So what I gotta do, I gotta spin this giant around. Oh, man, tell you what, this thing is heavy. So what we gotta do is just take the brackets apart. Got tons of screws on them. Okay, I think they're going to come loose now. Then we get to see the output transistors. Okay, so that's how nice this is. There we go. So this is one set of output transistors, and then we got another set on the other side. So these are connected to these little brackets that you see there, and then we got markings on them, and we got some stud diodes. And we got some, I believe might be, let's see what they are. Let's see. I believe it might be a CSR. Let's just undo these, because I'm not going to be using this again, so I'm just going to take everything apart. In the name of science, as some people say. Not just because of science, because it feels good to take things apart. And because we can. Why not? Ooh, wrong screws. Wrong screwdriver, actually. The screwdriver doesn't work properly. Alright, so let's see. Jesus, look how thick these wires are. Yep, CSR, CSR2. Okay, so what we need is a wire cutter. Poor little wire cutter. Doesn't stand a chance with these thick wires. So this one doesn't have any transistor on it. Oop, nearly knocked the camera down. Tell you what, this is this. Oh, now I know why this doesn't bloody work, because it is broken. And this one is rubbish. I really need to get some new screwdrivers. Probably need to get an electric one. Definitely actually need to get an electric one because I take a lot of things apart, so I don't want to sit here and start taking this. So this heatsink was just for the CSR, and then what we have here, massive, and then that is bolted to these bolts over here. Oh. Whoa. Let's just take one apart. There we go. Massive. So that is screwed into this. There we go. So that is screwed into this, and they're using this to couple this into the heatsink for the heat transfer. Instead of making a hole here and putting this through it, they've done it this way. Why? Because this won't fit inside here probably. Or it would. No, actually it would fit in there, so no idea why they've used this configuration to put this like so into it. But I'm sure they had the reasons. Who am I to tell them what to do? Okay, so I don't see any transistor at all actually on these. This is just, we got some stud diodes, and then we got another CSR there, and something that looks like a heat sensor or thermal sensor. Yeah, thermal sensor, not a heat sensor. Yeah. So this whole heatsink array was just for the SCR and the stub diode and the temperature sensor. And then we got this one. I'm just gonna take it apart. Yeah, it's only this one actually. Ooh, now I see. I thought that each of these heat sinks had 2 transistors on them. But I was wrong. Let me just take it apart and we shall see. So I would imagine that transformer probably weighs about close to a 20 kilo maybe. If this whole thing is 52 or 53 kilogram, actually if it's at the back how heavy it is, let's see, 116 lb, so we got 52.5 kilogram. Yeah, the guy who brought this delivered to me, he was a elderly gentleman, and he had a little trolley to bring this into my my house, but I told him, you just sit inside your van and let me just take it, because these are heavy. I don't think these are good for you to lift. He was about to lift them, so I said, no, you just relax and let me just take care of it, don't worry. So here we go. We got 1, 2, 3 heat sinks, and each heat sinks got 4 transistors. So we have 12 transistors in total, and these are, I don't know if it's visible, there we go, the stupid camera to focus, there we go, Motorola 2N3772. And then we got our pass transistors. We got the power transistors at the bottom, and then we got some other pass transistors over here, and then we got like a bus bar kind of configuration, and they're all tapping from those bus bars. There we go. So that was the pass transistor section. Oh, nope. still very heavy. I would have thought that it would have been less heavier now, but no. Okay, so these are the output connection here. Let me just spin this around. Oh man! Tell you what, this bloody transformer is heavy. Oh yes, we got all the screws falling down. Never mind. Alright, so you gotta cut this. You're gonna cut that. And then we got some wires going to the front. Alright, so what I'm gonna do, I'm gonna cut stop the camera now because it's gonna cut off, and then we're gonna carry on with part 2. Anyway, thanks for watching part 1. I've only managed to take in 25 minutes, managed to take just the past transistors out. But anyway, we're going to get to the good section in part 2. Anyway, thanks for watching. If you liked the video, please give it a thumbs up. And until part 2, goodbye and good day.